Okay, so I'm doing a different recording place, so things are a little bit different, but it's Pi Day, and I fixed my fake circle pi program. So let me just, or I have an idea to fix my fake circle pi program. So let me go over that. So this is the original program, just briefly to remind you. The idea was I have this ball connected by a spring to some center point, and I give it an initial velocity, which I don't even know if it is a circular motion, and then I let it run for a while, and then actually let's run this. So then it runs for a while, and it's not rendering right because it's going so fast, and then it kind of settles into a circle because there's this drag force on there, and then once it gets into a circle, then it has a constant radius. This is a plot of the radius as a function of time, and then I use that to calculate pi, and it didn't work too super great, but I think I can do it a lot better. So let's just copy this program because I don't want to destroy that one. Now I'm right at the point where I'm thinking if I even display it or not, and I don't even display it to tell you the truth. I kind of just want to start over. Okay, so let's just say, let's just call this, let's just not display anything. So let's say cent is just a vector. I mean, we've already seen what it looks like. And then ball is just a vector. Should I call that R? No, ball. This is called ball. Ball is just a vector. It's just a position. Oh, and that's what I did was I went back and gave it another initial velocity after I ran it for a while just to see what it looked like. Oh, crow. Okay, so just delete all this stuff. So it's just a vector. And now I can't do ball.m because it's not an object, so I have to change that to m. I'll change that to p. P equals m times the velocity, which is that vector right there. T graph, fine, leave that. So now I don't need the rate. R is fine. And this is going to be this ball minus cent. I know it's sloppy, but come on. B dot, this is P and M. Norm R. F, that's fine. P, ball, P, M. That looks good. Then let's just delete everything else. Let's just see. It plotted that. Let's see if it works right. And say that's fun. Leave it as a copy of fake circle and run it. And it didn't run. Did it not run? What did 17 f drag. Oh, ball.m. I deleted the m. Okay, good. So we got that same plot that we had before, and I ran that for 40 seconds, and it looks like it's fairly stable. And then what I did was I just used that value of r, but I don't want to use that value of r because that r is still fluctuating a little bit. So what I'm going to do is run it for, let's say, 10 more seconds. So let's say, and then I'm going to average the r and average the velocity, and then I'm going to use that. So let's say r list is a list, and v list is a list, empty list. Now I'm going to run it again while t is less than 50. So I'm going to do the same stuff. Let's just copy this. Undent that. I do not need to plot it anymore. But I do want to update the position, add this position and the velocity to the list. So r list equals r list plus r mag. I only want the magnitude of it. So I'm adding the scalar value of the radius in each time section. And I'm going to do the same thing for the velocity. V list equals V list plus mag P divided by M. That's the velocity. Okay, so now I've run it for 50 seconds. The last 10 I have data. Now I need to get the average list. So I need to average everything in that list. I think there's probably a way to do it, but I'm going to do it manually. So let's say r sum is equal to 0. And then for RI in our list, this will go through each item in our list, and RI is each item in that list, and want to add that to RSum. So RSum equals RSum plus RI. And then I can find the average. R average equals the total, our sum, divided by the number, and that's going to be the length in our list. Now I just need to do the same thing for the velocity. V sum equals 0. For VI in VList, V sum equals V sum plus VI. And then I can say V average equals V sum divided by len V list, which should be the same as our list, but you never know. Okay, so now we can just, let's just print this out, just make sure. Print R av and print V av, just to make sure it's running. Oh, something bad happened. So it did that stuff. It should do that again, right? Something crashed. I didn't save it either. Okay. So it got down here. It did that before. I didn't change that. Let's just try saving it and running it. I mean, I don't get it. Okay, let's reload this. I'm reloading the page. What the heck? Nothing's working on here. Close tab. Let's just try reopening it. Okay, so I think it was getting down to here, so let's just how do you, I want to comment out all this stuff, but I'm not going to do that. Let's just do this. Let's put some print stuff in here. Print step 1. Print step 2. Let's see if it gets there. He's not doing anything. Well, that's weird. Maybe it's, let's just close this tab again and then go to Trinket. And let's try a different program that I know runs, right? I ran it. My trinkets. Copy of, let's do fake circle pi. That one was running, right? Okay, that one runs. It ran, I know it did. Okay, let's just do this. My trinkets. You know what? I think I did this one twice. Let's just delete this one. Can I delete this? Trash. I wonder if that's the problem. I had two that were named the same thing. Let's try running it one more time. No? Get that. Okay, let's try. Okay, one more thing. My trinket. Copy of fake circle. I'm just going to cut all the stuff that I know. I know this other stuff works, so I'm just going to take from here down, and I'm going to cut it. Now it's cut. Now I'm going to save it. I know that stuff works, right? I did it before. And let's run it. Okay, that's working. Okay. So what did that do? Okay, let's just cut this part. I mean, that should work, right? Okay. Now, let's cut this part. mean, it's the same thing. Okay, so there's a problem in here. Where's the problem? It's the same R. Let's see. Let's close this tab. Let's open it up again. Okay, so there's a problem in here. So if you look up here, I have while t less than 40, R, I got that, F drag, it's the same thing, right? I mean, it's the exact same thing. What if I just copy this and just literally paste it? I mean, that should work, right? Because it ran before. And I put step 2. Okay, it got to step 2. Let's see if it got down here to step 3. What did I do wrong? I wonder if I made my list too big. I wonder if there's a maximum list size. So let's say 43 seconds. And let's just do one of them. So I'm going to say rlist equals rlist plus mag r. Crud. Oh, it did that. Okay. So I think that's just slow. Okay, so that's 3 seconds is still a lot of stuff. Vlist equals vlist plus mag p divided by m. Let's just run that. I feel dumb doing it, but I think I just have huge lists here. Okay, it's working. So now I can do what I did before. So I can say rsum equals 0 for ri in r list. Rsum equals rsum plus ri. And then I can say rav equals rsum divided by length of r list. Now do the same thing. Rvsum equals 0 for vi in vlist. Vsum equals vsum plus vi. Vaverage equals vaverage divided by length of vlist. Okay, let's see if this works. Print rav. Print vaverage. So if this works, what happens is that list operation is just like super slow. That's the reason I didn't save it. Wait for it now. I think it's just slow. Yep. That print step 2. Okay, I never printed, but I didn't print those. Oh. Undefined is not an object dividing vaverage divide. Oh, vsum. I gotta run it again. Let's make this 42 seconds. Okay, so now I have my average. Now I'm going to start over again. So now I'm going to say t equals 0. And I'm going to say the initial conditions ball is equal to vector r average 0, 0. So it's on the x-axis. And p equals m times vector 0 v average 0. So it's with that average velocity, with an average velocity and an average position, so it should be in the circular mode. It should move in a circle. Now what I'm going to do is say while ball dot y is greater than or equal to 0. So I'm going to let it go a whole half circle. Let's do a quarter circle. Ball dot x is, well, it's greater than 0, right? Because it starts at our average. It's going to be moving back towards the to the left, and it'll get to it'll be a quarter of a circle. So, but other than that, everything's gonna be the same as up here. I don't need to plot it. So let's just copy that. Right there. I don't need the plot. Okay, now I also want the distance it travels. So s equals 0. I'm going to add up the step in each part. So I can go down here and say s equals s plus. If you look up here, this p times dt divided by m is delta r. So that is what I want to add on here. P, the magnitude of p. I don't really care about the direction, times dt divided by m. So I'm adding up, and now I have the quarter arc length. So once that's done, so I can say, let's say I have the circumference is, I have this. C over 4 equals, let's see, circumference is going to be 2 pi r divided by 4, right? So C is my S. So pi, I'm just thinking backwards. I'll call it pi is going to be equal to S over 4. That C over 4 is my S. So I have to multiply it by 2 because it's multiplied by 4 divided by 2. So 2 times S. So 2 times S divided by R average. That will give me my pi. Let's see if that works. So P pi equals 2 times S divided by R average. And then print pi calc equals, you can't say it, call it pi because pi is already a word. That. Okay, let's see how that works. Remember, it takes a while. 3 point, look at that. See, that's pretty good. Okay, that's much better than the value I was getting before. And in fact, I think I can make this much better, even betterer by doing a half circle where y is greater than or equal to 0. Let's just try that. And that'd be a half circle. So a half circle, I'm just having trouble with this visual in my head. So this would be pi over 2, 2. So it'd just be, I think I just multiply by, just take S divided by R average. And let's go up here, while ball dot y is greater than or equal to 0 because it starts at 0. So 3.1418, which is really good. 3.1415 is the answer. 3.141. Okay, it's better the other way. But still, I'm pretty happy with this. You could even make the time set smaller here. You could do a full circle, but that was kind of where I was having the problem. But I feel much better about this code. I'm going to save it right now. I'm going to give it to you. Hopefully you enjoyed this. I'll talk to you later.